Hi there, I'm playing with junk again. Guess what this is? It looks like a PC. It looks like an old high class workstation with a massive aluminium front. It has a power switch. But unlike a PC, it has a port to connect some kind of hose. Well, maybe we should turn it over, because this side does definitely not look like a PC. Except maybe this side we have a power supply, a fan, a grill where air comes in or out. We have a couple of electrical connections. And we have a lot of mechanical hose connection, quick release hose stuff, big tube here. Some ports are labeled. We can see a O2 port, which means oxygen. We can see 50Q, SQ, DIR minus and plus, wall valve, test max. Okay, I will tell you, it's a medical device and it's used to test the function of your lungs. So it measures the lung capacity, it measures the gas exchange, how much oxygen there is when you breathe in and how much oxygen remains when you breathe out, the amount of nitrogen and carbon dioxide, and you hook up a PC to that port here, or that port, maybe the I/O port should be the one that goes to the PC, and then you'll get a lot of graphs and stuff, and if you're trained to use this thing, you can tell the patient if he is healthy or not. And if you want to know more about this thing, or how it works or what it does, just Google that, Vmax Encore. Yeah, you will find even videos on YouTube about that, that tell you in detail how it works, what it does. Yeah, I'm not going into that, I'm more going into the machine to see what's inside and probably how it works. Well then, cover is off and it looks pretty complicated. I got two machines of this type. One was already disassembled and I think this one has all the parts still inside. And one reason why I took it home are the two pressure sensors here. I can show you those a little bit closer. We have two of them, and according to electronic suppliers, these sensors here are still around $400 each. It depends a bit on the range, on the pressure range, and on the precision, but they are definitively not cheap. So maybe I can use one or two of them for another project, maybe not, but I will definitively save them. So maybe someone else needs one, who knows. Then we have some kind of sensor, or sensor device here with a hose going in and another hose going out. Then there is another sensor here which is strapped with some Velcro tape, probably because that has to be replaced frequently. Let's see what's on the label. An Electrochemical O2 Sensor. Okay, so that thing measures the amount of oxygen in the air. Okay, then we have more sensors down here. Well, I think I will start to take that thing apart. By the way, the unit is from 2007. That's what the label on this side tells us. Whoops. Date code July 07. Can see that. So it's not so old, 12 years. But if we look at the power supply, well, I don't know how familiar you guys are with power supplies, but this design here, especially with this cramped secondary side with absolutely not a single SMD device on board, that looks like a power supply from 1990. So they are using a pretty old design here, and probably, I don't know, maybe the entire box is an old design, but they are still used as it seems. So, well, it works. One reason could be this is probably an approved power supply by medical standards, so it has all the certificates, all the tests, and if you have that, because that is a very complicated and expensive task to get all these certificates, you better don't change a lot, because if you change something, you need a new process of certification. So, well, that's probably why it looks so old-fashioned. Well then, so I got a lot of stuff here, and you may notice I have some boards twice, because I also took boards from the other unit I told you about, and I also found that device here. So, of course, it looks like a medical device. It has no writings, no manufacturer. Maybe it's a cheap Chinese clone. They also sell it. You can have that from AliExpress for about 50 bucks. And what it does is relatively simple. Piece of cardboard. You place that in, and it punches a piece out. So after some googling, I found this is a Kerosene bone punch. That's the name. So they probably use it to punch holes into bones for whatever reason. Maybe to get samples, maybe to install, I don't know. I have no idea. If you know, please tell me in the comments. A Kerosene bone punch. And if you absolutely want it, I will probably give it away because I have no use for that. Okay, let's go to the electronics. So I think the most interesting parts here are these sensors, because, well, who knows how an oxygen sensor actually works? I don't know, but maybe we will find it out. So that's the mounting frame and the board where this oxygen sensor was mounted on. Let's have a look on the board. Maybe we will find something interesting on it. Maybe not, who knows. Made in USA. Yeah, it looks a little bit old-fashioned, but it's made in the USA. By the way, I saw marking copyright 2000, so the board design is probably a little bit older than the device itself. We have two LT chips, LTC 1151. Is that true? Yeah, I think so. Something like the old Teledyne logo. Ha! Yes, it is. Teledyne Analytical Instruments. Model UFO 100 or 13D. Well, decide for yourself. Made in the USA. Software version not applicable. 2004. So we have all kind of parts from 2000 to 2007. So the board itself is from 2001. Okay, all over the place. So I would say that's two analog to digital converters. Okay, it seems it's not a digital analog converter, it's a zero drift operational amplifier, a dual one, so two amplifiers in one case. So that's just an amplifier board that connects to the DA converter, which I have seen. Well, I'm pretty sure that's it. Burr Brown, they make a lot of digital analog converters. There is another one, and the chip is named DAC, Digital Analog Converter. Very simple to remember. And that's a bit a special design here. It seems they have a normal footprint for a dip package, like this one here. But probably the chip was not available anymore, so they made a board as with an adapter here for the dip package. So a little workaround if a specific chip is not available anymore. By the way, another interesting part is that transistor-like looking device here. But that's not a transistor. It's an, well, there's my magnifier lens. It's an AD581, and that's a precision voltage reference. Similar to those used in digital voltmeters and stuff like that. But with the difference that this one puts out 10 volts and exactly 10 volts. According to the data sheet, it's laser trimmed to exactly 10 volts with a minimum or almost no temperature drift and aging and all that stuff. So that's a super precise 10 volt voltage regulator. Well, voltage regulator is maybe not the right term. It's not used to deliver power, but yeah, it delivers exactly 10 volts as a reference. Okay, let's go to the interesting end of this oxygen sensor. We have a connector, we have a trim pot. That's almost everything we can see. We have a connector for a hose that can be screwed off. And we have another connector for a hose that is simply a plug on and off type. And well, that's more or less what we can see. But I definitively want to destroy that, so let's see, there is nothing under the label. Okay, too bad. So there is nothing to see. Okay. No, definitively not a crack, nothing. We probably, I know you guys only want to see me cut in my finger, you want to see blood, but I'm not sure if I can fulfill that wish. That's my old pocket knife screwdriver trick. Okay, there's already part broken off. Okay, another one. Yeah, that's quite massively glued together. Okay, that's the wrong method. Let's try another one. Okay, that's it. A sensor device, some grid. So it was named Electrochemical Sensor, so it probably works like a battery. When oxygen comes in, a chemical reaction produces some, it is relatively heavy. So there are some wires. I hope they are platinum, but I don't think so. Okay, they're just welded. Oh, okay. Some foam, some kind of coil. Ah, okay, that's a temperature sensor here. Some kind of NTC, PTC or whatever. It has two wires, RT1, yes, temperature sensor, couple of resistors, that's it. Yeah. And we have, oh, there's some liquid inside. There's some bubbles bubbling around. And I see some crystals. And the white spot here, that's thermal grease for the thermal sensor. It's hot today, really. It's almost 25 degrees, shortly one day before Easter. Okay, thermal grease. And I'm sitting here in my t-shirt because it's too hot for a pullover. So, okay, this looks like a thin plastic window here, so I will not break that because I don't know what liquid it is. It doesn't look extremely dangerous, but maybe it's just water. I wonder what the crystals are here inside. Need some more air. Yeah, I think we can see that. Okay, I have no idea. There is a grid to let some gas in. Well, somewhere gas needs to go in. And then a chemical reaction probably makes some voltage between the 2 points here. I don't know. Maybe we can Google that, but I don't want to do that right now. Okay. What else do we have? Let's move that away. Okay, that's also an interesting contraption. It's two glass or plastic, yeah, sounds like plastic, tubes with some hoses attached, just a rubber cover here, one tube in, one tube out. There are two holes here in the bottom. Okay, maybe some sort of silencer or a small reservoir for gases, because this one is a pump, a small compressor with a in and out. There's a little arrow, maybe you can see that. Yes, I think that is in, that is out. And an electric Maxon motor. Okay, that's nice. Swiss-made quality motor. Yes, Swiss-made. Here you can see it. That's probably the best electric motors you can get. I'm surprised to see such a quality motor on a simple pump, but that's medical stuff. Nothing is too expensive. Let's open it because I have another one just in case I can't reassemble that. So probably my Torx here will fit. Yes. Let's see what's under the cover. Under this cylinder head here, looks like a little V2 engine or a boxer engine, like the old Volkswagen Beetle. Of course, that one had 4 cylinders. Okay. There's not much inside. Okay, that's some sort of rubber membrane here. Okay, what's the voltage? Type, blah, blah, blah. 4.2 volt DC. Okay. knf.com. That's this. KNF. Made in Switzerland. Okay, that's the reason why they use a Swiss motor, because the whole device is made in Switzerland. They say 4.2 volts. Okay, let me type that in, 4.2 volt, and give it 500 milliamps for the start. Power on. Okay. And yeah, so the membrane goes up and down. Don't know, yeah, you can see that. And I expect to have the same principle on the other side for double efficiency. And by the way, we can see the valves here that's okay. Okay, so this is the intake. Yes, no, probably, maybe, I don't know. Yes, this is the exhaust valve, opens when air comes from below. And this is the intake valve, probably opens when air comes through that hole here. So I just put that together to see if it still works. Well, it's made in Switzerland. That must work even when you took it apart, because it's perfectly serviceable. Well, I hope so. I hope I do not over tighten these screws. I don't have much feeling here with this screwdriver. Okay, that's, yeah, it's pretty simple. Okay, yeah, that's already going around. Okay, I think that's it. Power on. Yeah, it blows and it sucks. Blows and sucks. What a sucker. Okay, what about the pressure? Well, not so much. Maybe half a bar or something. I don't have anything to measure that at the moment, but it works, and it will probably be enough to pump up a balloon or, well, a fancy surprise box, something, I don't know. Okay, that's the same thing again here. So how about the pressure sensors? I think I explained them enough in my last video. 1, 2, 3 connections. That's voltage in. Well, maybe not that, I don't know the right order, but it's one pin is voltage in, one pin is ground, and one pin is signal out, depending on the pressure. There is a pressure port and also a vacuum port. I think that one is the low pressure, the high pressure port. Then we have pneumatic valves, which is essentially a coil with a magnet inside that flips forth and back, opens and closes the valve here, in, out, yeah, or maybe that's in, and then it switches from one to the other. I don't know. I have to test that, but that is probably something I could use. Driven with 5 volt and a maximum pressure of 10 psi, which is not very much, but yeah, I don't know. Maybe. Okay, that's an interesting sensor here. By the way, it's almost the same principle as this one here. Maybe here we can see a little bit better what happened or what's happening. There is an input and an output, or vice versa. Here we have either a light source or a sensor. I would say it's probably a light source, because the complicated device here, that looks more like some kind of sensor. Well, how does it work? I have seen similar sensors like this one for carbon dioxide. Probably that's the same arrangement here. I don't know why we have two different sizes. Maybe one is for nitrogen. We already had the oxygen sensor. And for example, for carbon dioxide, it works like so. You have an infrared source. You measure the amount of infrared that travels through this chamber here. And the more carbon dioxide is in this chamber, the more of the infrared gets absorbed. So you get less infrared on the receiver here on the bottom. So I assume this is the receiver. Let's take it apart. Maybe we can see a little bit more. And from the drop in infrared radiation, you can tell how much CO2 is in that gas. And probably the other sensor here is with another wavelength for another kind of gas, or maybe that's the CO2 sensor and this is for another kind of gas. But if we look at the principle, we see the same board here with this two connector device. And underneath this cardboard shield, we also have this round sensor here with some op amps around. Maybe, yeah, I think it's not exactly the same, but a similar board here. Okay, let's play with that one first. Okay, so we have a lot of thermal grease. I don't know why this is necessary. Let's cut that away. So first we have this chamber. There's a glass window here. And on the other side we have probably a light source, because this device here looks more like a sensor. Maybe it's just a guess. It's a Peltier thermoelectric cooled infrared sensor. That's why it has so many connections here. It's a thermoelectric cooler. Most likely the come on, focus. Okay, let me change that. I have this manual focusing thingy. Okay, so there are two thicker tracks here. That's probably this cooler. Then we certainly have a temperature sensor for the thermoelectric circuit to be monitored, and then we certainly have an output, probably there two here. I don't know, do we have a code? No, there's just a handwritten number on it. No code. U11. Okay, I don't know. What is that? Det 1, that certainly means detector 1. So one thing is clear, this is not the emitter, this is the detector of whatever. Okay, so I think I put that in here again. And on the other side, well, I would like to see what's inside this thing here. So the whole thing with, I have to adjust my camera. I'm always off the camera so you can't see anything. Well, the whole glue part here moves around. Maybe I can do that. Yeah, it's coming out. Seems it has a similar case. Ah, okay. So that's the chamber. It's just, well, a glass on one side, a glass on the other side. And that's, I don't know. Yeah, there is also a mirror-like glass on top. And I see a little bit something below, but I have no idea what it is. Okay, I don't know if you can see it in the camera, but there is a little wire coil, like a filament of a light bulb. So I think, yeah, it's a long wave infrared emitter, most likely. So they simply heat up this coil of wire, maybe not red glowing, but at a lower temperature. And with the right filters and stuff, you get this infrared, this long wave infrared. It's in principle a heat, a beam, a heat radiation. So in the spectrum of heat waves. Yeah, just a piece of wire that gets hot, emits infrared, which is picked up by the sensor here. Maybe with the right filters. I'm surprised that there is no temperature sensor here. Maybe when it starts up, this calibrates with the sensor, with this detector here. I don't know, but maybe it's not so important. Maybe it's just a question of how much current you let go through this thing. But that's the infrared emitter, an infrared detector. You put some gas between and you measure the difference of how much infrared gets in or not. Okay. And this device here, of course, works in the same fashion as the same emitter, the same or maybe a similar receiver or detector. And the difference is there is a longer tube between the two, so more gas can be analyzed, or maybe the effect is stronger with a longer tube, so the light or the infrared radiation has to travel a longer way, no, that way, from here to here. So I don't know, maybe the other is CO2, carbon dioxide. This one is probably nitrogen, or the other way around. Who knows? Maybe you know and you can tell me. Okay, so the last thing I want to do is to play a little bit with this voltage reference. So I have to unsolder that and let's see if it still works. Well then, that's the device. It has 3 pins. If you hold it like this, it's too small. Okay, with the reference tab here, then it's input, output, and the ground pin is connected to the case, which seems logical. Input voltage, absolute maximum 40 volts. Let's give it 20 and let's have a look what comes out at the output. Power on, negative to the case, ground, and then we measure here and we get 10.00081 volt. And again, just in case you do not believe me, 10.00085 volts. Okay, that's pretty close to 10 volts. Maybe it will get a little bit better when it's warmed up. Current is 1 milliamp. By the way, the output can supply minimum 10 up to 20-25 milliamps. So whatever you do with this thing, you can also connect a little bit a load on it. Okay, pretty good. Okay, LT581. Did I say 531 before? Well, it's 581. 581, 10 volt reference. There is also an LT580 with a 0 at the end. That's a 2.5 volt reference for all those who need a 2.5 volt. By the way, this thing is worth 20 bucks. New, of course. Okay, thanks for watching. See you next time.